Alright, this is the video for the geometry chapter review, chapter 10 for Friday, March 20th. I'm running into some technical difficulties where my videos are too long for YouTube to allow me to upload them, so I'm going to try and make this somewhat short. You should have a review sheet in your hand, okay, so you need to make sure you read through all the theorems, understand the theorems. We're going to highlight a few of them, going through here, parts of a circle. Okay, remember, if you have a line that goes through the center of the circle to a point on the outside, this is your diameter. Halfway from the center to a point on the outside is a radius. Any line that goes from a point on the outside to another point on the outside is called a chord. And of course, this is your center of your circle. Based on this, we first started talking about circumference, which is your distance around the circle. And your circumference is equal to 2 times pi times the radius, or pi times d, because remember, twice the radius is equal to the diameter. And you should be able to, given a radius, you should be able to come up with a circumference. Given a diameter, you should be able to come up with a circumference. You also have on a circle, well, let's take this example. This right here is a central angle, because your central angle has your vertex in the center of the circle. If I were to add up, I'll get rid of this chord right here and use this illustration. Let's say I have that angle, that angle, that angle, and that angle. The sum of those angles is always 360 degrees. If I have an arc of my circle, like arc AB, which means along here, that's considered a minor arc because it's less than 180 degrees. But let's say I wanted to denote this arc from A all the way around to D. If I just did AD, I would think that I'm doing this. So what I have to do is I have to put, for a major arc, for an arc greater than 180 degrees, I have to put in 3 points. So if I said arc ABD, I would know that I'm talking about this big space right here. Again, this is a central angle. If I'm talking about the measure of a central angle, let's say this is 45 degrees. The arc out here would also be 45 degrees. Now that only works on a central angle. Okay, you do have several theorems on your study guide that discuss that. Like I said, I'm just hitting the highlights right now. If we need to, we'll go over more after you do your review homework on this before you take your test on it. We also talked about inscribed angles. Inscribed angles are ones that the vertex is on a point on the circle and it's not in the center. Remember, the inscribed angle is half of the arc that it is inscribed. So let's say that that arc is 80 degrees, then angle A would be equal to 40 degrees. Obviously, if I have two angles that inscribe the same arc, then that's also 40 degrees, and they would be congruent to each other. We talked about a inscribed angle of a semicircle. Let's say I've got that goes through the center of the circle. And I've got that angle. Well, obviously the measurement of that angle is 90 degrees because that whole thing is 180 degrees. You had a theorem that talked about quadrilaterals that were inscribed in a circle. They don't have to be regular quadrilaterals, they just have to be four-sided figures, like something like that. Consecutive angles on these are supplementary. So let's say I have angle 1, angle 2, angle 3, and angle 4. If I add angle 1 and 2 together, it's 180. 2 and 3 together is 180, 3 and 4 together is 180. Then we began to talk about lines that are tangent to a circle. And we did stuff where we have the circle and we have a line that comes out like that, and we said we know that it is tangent to the circle if it joins at a 90-degree angle. And what we did was we checked out to see whether it would work in Pythagorean theorem to see if it would work. And there's a theorem that says if it does work, then it's tangent to the circle. We also use stuff like this to figure out unknowns. Like for instance, let's say I know that this is 20 and this out here is 16, and I want to know what that is. Well, knowing that it is tangent to the circle, I would turn around and go 16 squared plus x squared is equal to 20 squared, and I would work backwards to solve it. I also had a theorem that talked about two lines being tangent to the same circle, and we found out that those two lines would have congruent measurements. Let's continue on here and show you an example problem if I can get it drawn. Okay, let's say that I know that this is 12 from here to here. Obviously these are not going to be to scale. Okay, and I know that this whole thing is 52. And let's say I want to know the perimeter of this triangle. Well, if this is 12 from here to here, this would have to also be 12 from here to here. This would have to be 18 and 18. Then I would have to take my 52 and subtract my 18 from it. So this would be 34 right here, and this would be 34. Then to find the perimeter, I would add up all those numbers. We also talked about secants. Secants are lines that intersect the circle in two spots, so those are two secants. And we talked about to find an angle that is inside. Now understand, those are not central angles, those are just inside angles. Let's say that this is 45 degrees right here, and this is 55 degrees. Our theorem says angle 1 is equal to 1/2 of the 45 plus the 55, which when I add those two together, I get 100. So angle 1 would be 50 degrees. Those are two secants that join in the circle. We also have like two secants that join outside the circle, okay? So those are two secants that join outside the circle. If I'm trying to find angle A, and I know that this out here is 80 degrees, and this right here is 20 degrees, then angle A is equal to 1/2 of this bigger arc that's inscribed minus the smaller arc that's inscribed, which is going to give me a measurement of angle A of 30 degrees. Hopefully you remember all this. We also might have a tangent and a secant. Again, notice that there's two intercepted arcs, so really this is a lot like the last theorem. If this is 200 degrees out here, and let's say this is 40 degrees, then the measurement of angle A would equal 1/2 200 minus 40, or that would be half of 160, which is going to be 80. Forgot my A in there. Okay. Same thing with two tangents. Normally when we're doing these video things, we'll have a pause for you to stop and do a problem, but because I'm trying to get it all in here before it cuts out on me, we're gonna go forward here. Let's say this is, from here to here is 180, and let's say this is, I don't know, 60. Then angle A would equal 1/2 of 180 minus 60. So 1/2 of 120, so angle A would equal 60. Okay. Then you moved on to the part that had to do with your homework that you did for me on Tuesday. And this has to do with segments, and it has several theorems here, and again, they're all on your study guide. Let's say I have two intersecting segments here, obviously not drawn to scale, but I have those. If I want to know the measurement of x, I go this times this is equal to this times this. So I have 3x is equal to 12, or x is equal to 4. So my missing spot right there is 4. I also found that if I have two secants that form outside this, then let's say this is, I don't know, 4 and 5, and let's say this is 3 and x, and I want to solve for that. Okay, it says the part on the outside times the whole thing, so times 9 is equal to the part on the outside times the whole thing, so this would be 3 plus x. So I've got 36 is equal to 9 plus 3x. I would subtract the 9, so I'll get a 27 is equal to 3x. And when I divide, I get x is equal to 9. Then you had a theorem that had to do with a tangent and a secant. That theorem says the part on the outside, that's the tangent part squared, or that multiplied by itself, is equal to, and let's go ahead and do an x here and do a 3 here. So 4 squared is equal to the part on the outside times the whole thing, so 3 plus x. So I'll get 16 is equal to 9 plus 3x. I'm going to subtract the 9 and I get a 7. 7 is equal to 3x. I'm going to divide by my 3. So x is going to equal 7 divided by 3. Okay, obviously, because I'm making up numbers, they're not coming out even necessarily. Then the very last thing you did in this chapter was the equation of a circle. Okay, the equation of the circle is basically x minus h squared plus y minus k squared is equal to r squared, where this is the center of your circle and that's your radius. If I had one that said x minus 2 squared plus y plus 4 squared equals 81, that would mean my center is at 2, negative 4. It's the opposite sign right there. And then I would take the square root of 81, which is 9. So I'm going to put that point, going to make a really small graph here. So I'm going to go 2, 1, 2, 3, 4. And then I'm going to go up 9, down 9, to the right 9, and left 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here, over here, and over here. Okay, so you're going to have some problems like that. On your review homework, it should help you know whether you understand that, okay? And so I'm going to give you the review homework. If you struggle with it, just send me a text, and obviously you're going to scan it, send it to me. I'm going to correct it and send it back to you and make sure that you're ready for this test. So on page 581, 12 through 56 even, And this will be due Sunday by noon. So you have a little bit of time to do it. And then on Monday will be when you'll receive the test to take. And if there's any problems that we need to figure out before then, we'll work on that part of you checking the test on Monday. Alrighty,